All right, let's jump right into this explainer. Today, we're tackling something absolutely crucial for any web developer: how websites actually remember you. We're focusing heavily on those core Week 3 learning outcomes. Implementing file I/O operations, secure file uploads, managing user state with sessions and cookies, and finally, creating basic user authentication. If you've ever wondered how a web app keeps you logged in or securely handles that profile picture you just uploaded, well, you're in the exact right place.
So here's the fundamental problem we're up against: web amnesia. By default, the internet is completely stateless. That means every single time you click a link, refresh a page, or submit a form, the server basically forgets who you are. It literally treats every request like it's coming from a total stranger. So the big question is, how do we bridge that gap? How do we make a website smart enough to actually remember your preferences and keep your data locked down?
To figure that out, here's our roadmap for today. First, we'll look at how the web remembers you in general. Then, we'll cover reading and writing server files, followed by managing secure file uploads. After that, we'll compare sessions versus cookies and wrap it all up by building some basic user authentication.
All right, starting off with Part 1, how the web remembers you and how we overcome that dreaded web amnesia.
Think about what we expect from the web today. We fully expect sites to hold onto our shopping carts for days, to keep us logged into our dashboards, and to remember if we prefer dark mode over light mode, right? Well, to pull that off, server-side languages like PHP give us three main tools to work with: file handling, sessions, and cookies. And each one of these plays a super specific role in securely holding on to your information.
Which brings us to Section 2, reading and writing server files. Basically, the most fundamental type of memory. Sometimes you just don't need a massive complex database. You might just want to save a quick text file for system logs or some user feedback. That's where PHP's foundational input-output operations come into play. We use the fopen function to open a file, and we have to tell it our access mode. Like, are we just reading it with an R? Are we writing totally fresh data with a W? Or are we appending new data to the end using an A? Once it's open, we use fwrite to write or fread to read. And then, and this is super important, we absolutely have to use fclose to safely close that file and free up the server's memory.
Now, I cannot stress this next point enough. Security is absolutely paramount here. You have to validate and sanitize data before writing it to your files, especially if it's coming from user input. Let's say a user submits a contact form, and you're saving that directly to a text file. You cannot blindly trust what they typed. Malicious users will absolutely try to inject executable code instead of a friendly message. So always sanitize that data first, and make sure you're using try-catch blocks to gracefully handle any errors just in case the file won't open.
Moving right along to Section 3, managing secure file uploads, or how we safely let users contribute their own content.
Think back to the last time you uploaded a profile picture. What was actually happening behind the scenes? Well, it's a three-step dance. First, the user selects a file using a standard HTML form input. When they hit submit, PHP intercepts it and sticks it in a temporary holding area. That's the $files superglobal array. But it can't just stay there. As the developer, it's your job to use the move uploaded file function to grab it from that temp location and securely drop it into a permanent directory, like an uploads folder on your server.
But again, we have that trust issue. You simply can't trust any random file a user uploads. That's why strict security checks are mandatory. Imagine the nightmare if someone uploaded a dangerous executable script instead of a cute dog photo. To stop that, we strictly check the MIME type to guarantee it's actually an image. We also heavily restrict the file size so users can't just overload our server capacity. Oh, and we always rename the file. If someone uploads image.jpg, we might rename it with a unique timestamp so they can't accidentally or intentionally overwrite an existing file on the server. And of course, keep those uploads outside the web root if possible.
To put this into a real-world perspective, let's talk about image sizes. Modern smartphones take massive photos, easily 5 to 10 megabytes. If a user uploads a high-res JPEG larger than, say, 2 megabytes, you really should intelligently resize it before saving it permanently. By using PHP functions like getImageSize to check the dimensions and ImageCopyResample to scale it down, you're going to save a massive amount of storage space and guarantee your web pages load lightning fast for everyone else.
All right, let's shift gears to Section 4, Sessions versus Cookies, and how we manage user state.
I love this analogy. Think of sessions like VIP wristbands safely checked by a server bouncer, while cookies are more like sticky notes the user keeps in their own pocket. Both solve our web amnesia problem, but in totally opposite ways. Sessions hold your sensitive data tightly on the server itself. All the user gets is a randomized ID number to prove who they are. Cookies, on the other hand, actually hand the data over to the user's web browser to hold on to.
Because they are stored on the server, sessions are the absolute backbone of secure login systems. They keep your data safe across multiple page loads. When a user logs in successfully, we fire off session_start. Then, we can load up the su_session array with things like their username or access level. And because that data never leaves the server, it is incredibly secure. When they log out or close their browser, we just call session_destroy, and poof, all that secure data vanishes.
Then, on the flip side, we have cookies. In PHP, we use the setCookie function. We give it a name, a value, and crucially, an expiration time so it can actually stick around for days or months after the browser closes. We grab that data later using the superglobal $cookie array. But, and this is a massive warning sign, because cookies live on the user's computer, anyone can just open their browser's developer tools and change the cookie's value. Because of that, you should only use cookies for harmless stuff, like remembering a dark mode preference. Never ever store sensitive things like passwords or account balances in a cookie. Seriously, just don't do it.
Okay, let's bring it all together in Section 5, Building Basic User Authentication.
So, how does a basic login actually work? Well, the whole process kicks off with a simple HTML form where the user types in their credentials. PHP takes those credentials and checks them against our secure file or database. If everything matches up, we don't just blindly send them to the next page. First, we execute session_start and set a variable, maybe something like $session_logged in equals true. Then, on literally every single protected page of our site, the very first thing we do is check if that session variable exists. If it's not there, we immediately kick them right back to the login screen. And that brings us to a non-negotiable rule for real-world security. Never store plain text passwords. If you save a user's password as 1234 in your database, and that database gets hacked, the bad guys have everything. Instead, when a user creates an account, we use PHP's password_hash function. That takes 1234 and turns it into a long, scrambled, totally unrecognizable string of gibberish. Then, when they try to log in later, we use password_verify to see if the password they just typed matches that scrambled hash we saved. It is an absolutely critical layer of defense.
As we wrap up this explainer, I want to leave you with something to really think about. If a user can so easily manipulate the cookies stored on their own browser, what actually happens if your application trusts that data just a little too much? As you go out and build your own web apps, writing files, starting sessions, and setting cookies, just remember that managing user state is a really delicate balancing act between user convenience and rock-solid security. Always validate your inputs, never entirely trust the client, and keep your sensitive data securely locked down on the server. Thanks for joining me on this one.